So I'm going to handle the subject data structure. I'm Sumitha from CSC department. This is somewhat a very interesting subject. Uh, we interact with me. We make an interactive session. Then only you get involved. Also, more interesting about this. Okay. Uh, First of all, sorry for the disturbance. Okay, shall we can start now. First of all, how to know what is data structure? Anyone, please, can you tell from the name itself? You can say what does mean by data structure. Can I get it on the chat, please? Anyone? From the name itself, you can say what does mean by data structure.
Organizing data.
Yes, yes, very good.
Arrangement of data.
What ma?
Arrangement, ma'am.
Yes, yes. Data structure, the name itself, we can say data is arranged or organized into into one form in the memory. In the memory, why we are using memory in the computer system or programming? For allocating or storing some programs or some data, right? For that we need some structure, how we are going to organize, how we are going to arrange the data. Okay, this is the data structure. In definition, data structure is data organization, management, and storage format that enables efficient access and modification. For what reason we are going to organize mean? It is efficient access. We can efficiently access the data from the storage. This is the main purpose for data structure. Okay, data structure is nothing but it is arrangement of, it is the mechanism to arrange the data into the memory. In simple words, we can say data structure is a way in which data is stored on a computer. How the way the data is stored onto the computer. This is the data structure. Everyone is clear? Data structure is nothing but first of all, before going to the syllabus, I'm just give some introduction about this data structure and its application. Okay, data structure is the organization of data. For example, here in PPT, I have shown three diagrams. First one is the stack, next one is the list, and next one is the tree. This is nothing but types of data structure. This is the example for data structure, how we are going to organize the data. In the case of stack, we are organizing uh, like uh, uh, like one box. Okay, in the case of list, we are organizing in linear manner. In the case of graph, we are organized in the way of hierarchical manner. This is the example for data structure. Okay, shall we move on to the next one? Why is, thank you pa, is why do we need a data structure? Why we need means it is for used for accessing data efficient manner. We can once we are arrange the data in a proper manner means then we can get the data easily, right? In the, for example, in day to life we are using some bookshelf. In that we are arrange the data, arrange the books means we can easily fetch the book what we want. at the same manner, same mechanism is used here. Okay, efficient data search and retrieve. We can search the data efficiently, and also we can retrieve the data as soon as possible. Okay, this is what we are moving to data structure. Next one is specific data structure for specific problem. For example, some problem may use one type of data structure, some may use another type of data structure. So we need lots of type here, lots of methods here. In data structure we have organize for why we are data structure used for organizing data. For organizing we have lot of types and lots of methods. Which problem is efficient for which one, likewise we can select and use. And need to manage processor speed. From using with the help of data structure we can manage the processor speed. Next one, serve multiple records simultaneously, because in the case of list we are storing linear manner, we can access any data at a time. Next one, manage large amount of data and indexing. Also here we can manage large amount of data, very huge amount of data itself we can organize and easily fetch the data, because we are having here we are using indexing. With the help of indexing we can fetch the data. Okay, this is what we are moving to the data structure, and the real time examples are listed here. One is the dictionary. Okay, uh, from this example you can get a complete view about data structure. Data structure, the dictionary is one of the best example for data structure. In dictionary the words are arranged in some manner, that is the alphabetical order. Then we can search a data, refresh the data easily. We can we can collect the data from dictionaries very easy, because it is arranged in some manner. And next one is the Google Map. Google Map also one of the real-time example for data structure. In Google Map, all the locations are stored under one database. But how this is organized in India? For example, we take this India, our nation. In that India, we have multiple states. So it is arranged in tree-based structure. In India, we have multiple states, and in Tamil Nadu, we have multiple districts. Likewise, is arranged and organized so that it is moving uh, very neat manner. Next one is the Excel sheet. Here also we can arrange the data in proper manner and select the particular. For example, if you want to add some of the sorry, you are going to add a particular values, means we can fetch the 5 elements or 5 data, and we can do the addition easily. Okay, and so and so we can collect the particular data itself. If I want a particular subject marks only, I can fetch easily because it is arranged in proper manner. This is the real time example for data structure. Okay, everyone is clear what is meant by data structure? Data structure is nothing but it is the way of organizing data into the computer. Many types are there in data structure, and why we are moving to data structure means we can easily fetch the data and search the data, and also it gives many benefits. And also the real time example is dictionary, Google Maps, and Excel. Many of them, but I listed the main popular real time examples here. Next one, the characteristics of data structure. The data structures have some characteristics. The main characteristics are correctness, time complexity, and space complexity. These are the main characteristics of data structure. Once we are talking about data structure, we have to know what is correctness and time complexity and space complexity with respect to the data arrangement in the data structure. Okay, the correctness means is nothing but the data structure implementation should implement if interface correctly. You should have to we have check we can check whether the data are properly arranged and give proper interface between the input or output or user. Likewise, we can access data anywhere at any point. This is helps where the data structure is helps to we can fetch the data in any order. It gives better interface to the particular customer and organization computer and the OS. Likewise, it can give better interface. And also the time complexity. Once we are talking about the data structure, the time complexity and space complexities are very important one. Time complexity is nothing but running time or the execution time of operation of data structure must be as small as possible. That is, we can implement the data structure. We can arrange the data with the help of data structure, but we need the arrangement and we need the data in the proper arrangement. But also, we have to focus on the time complexity. That is, we can fetch the data as soon as possible means it is better. It is the best data structure, otherwise best methodology. Likewise, we can say, okay, the time complexity is most important. Which application which method in data structure gives the better efficiency with respect to the time, then it should be the best one. The data structure gives the best arrangement because it has many methods. So which problem need which type, then we can select respect to the particular what respect to our problem we can select. So time complexity is very important. Based on this time complexity, we can select the data structure types. Okay, also the same to space complexity also, how much memory it used. Okay, in the case of space, the particular which program or with which methodology accessing little amount of space means that is what best one. Right, in the case of time, which operation or which algorithm takes little amount of time to run a program, this is the best one. That is the time complexity. Next one is the space complexities, which data where which algorithm which process accessing a little bit of space compared to other means that is the best data structure. And this is the most important term to discuss about the data structure. Okay, this is the characteristics. Characteristics have three main characteristics. One is the correctness, next one is the time complexity, third one is the space complexity. Next one is the classification of data structure. In data structure, we have two main types. One is the primitive, next one is the non-primitive. Primitive data types we have already known, that is the integer. Uh, Students, have you studied in previous semester C? Have you studied C in previous semester?
Yes, ma'am.
Yes, ma'am.
Okay, then you know already. The primitive data types are integer, character, float, and boolean. These are the primitive data types. Primitive data types is nothing but it can be directly manipulated by machine level instruction. This is the primitive data type. This integer, character, float, and boolean values are directly manipulated. It can manipulate by the machine level instruction because it is belong to these instructions are derived from the machine level instruction only. So the computer will know these data types. The next one is the non-primitive data types. Non-primitive data types also have another two types. One is the linear data type and one is the non-linear data type. What is meant by linear data type? Can anyone? What is meant by linear data type or linear? What is meant by linear? please? Anyone? Or the name itself, you can say, ma. What does mean by linear? Students, what does mean by linear, please? Okay, no problem. Some
Sequential.
what pa?
Sequential manner.
Yes, yes, very good, very good. Linear is nothing but sequential manner. That is the continuous or continuous manner. Okay, one related to another. Likewise, it is stored. This is the linear data structure. The next one is the non-linear data structure. Non-linear means not sequential. That is random manner. Okay, linear manner means sequential manner. It is arranged in some order, some sequential basis. But in the case of non-linear, it is not sequential. That is, it can store anywhere. That is a random manner. So the under this linear data structure, again we have four types. Four types are four methods. One is the array, linked list, stack, and queue. In the case of non-linear, we have two types. One is the tree, and another one is the graph. Already you have studied in see the array. Array you have studied, right? So array is one of the linear data structure. Okay, linear is nothing but the data are arranged in sequential manner. That is the array. You can know, right? Array you have no array. In the case of array, the data are arranged in sequential manner. We first of all first we declare some array values, a of 10 or a of 5. Likewise, the arranged means declared means the memory locations arranged in continuous manner from 1 to 5. The data, the memories are the memories are data are organized in some sequential manner. Next one is the linked list. It is like a list. It is stored like list, but one to another is somewhat linked. The one data is linked to another data. Likewise, it stored. Next one is the stack. Stack is nothing but it is like um, how can I say, stack is not this is the man in the case of stack, the data is stored in the form of first in last out. First in last out means the data which is entered first is comes out last. Okay, this is the manner in stack we are going to discuss in next further sessions. And next one is the queue. Queue means here the queue, the strategy is first in first out. For example, we are entering or we can waiting in the queue. Waiting in the queue in shop means first which who are first waiting in the queue is served first. Okay, this is the manner sorry, used in queue. Okay, in the case of stack, we are using the methodologies last in first out, otherwise first in last out. In the case of queue, the manner is how the data is served means first in first out. Okay, this is the linear data structures. Next one is the non-linear tree and graph. Tree is nothing but tree and graph both are used to use the hierarchical manner. Hierarchical manner is used to store the particular data within the tree structure and graph structure. This is the classification about data structure. Data structure have two types, primitive and non-primitive. In primitive, under the primitive, we have four types: integer, character, float, and boolean. The primitive data structure, primitive data types are directly manipulated by the machine level instruction. But in the case of non-primitive, this is not the case. Here we have two types of data structure: linear and non-linear. Again, linear is divided into four: array, linked list, stack, and queue. In the case of non-linear, we have two types: tree and graph. Okay, this is all about the classification of data structure. Again, this some definition. Primitive data structure means it can be manipulated by machine level instruction. Non-primitive means derived from one or more primitive data structure. It is not directly manipulated by the machine level instruction, it's derived one. And linear data structure, already we have discussed, is the sequential fashion. It is stored like sequential manner. For that we have array, stack, and array, stack, queue, and linked list. Non-linear means it is stored like hierarchical manner. Okay, in that we have two types: trees and graphs. And next one is the static data structure means using static memory allocation. That is, data structure formed when the number of data items are known in advance. For example, we have one program in that some of the values or some of the values or some of the memory location we can find in static, I mean the compile time itself, that is a static one, right? That memory for a particular variable we can find the memory location in compile time itself, that is the static data structure. But the values are allocated in dynamic, that is a runtime means, that is the dynamic data structure. Next one is the application of data structure. These are the some of the application under data structure. All the CS, all the computer science subjects are some computer science subjects or topics are covered under only the data structure. Data structure is the main, very important and very main core topic under this computer science. Okay, without data structure we can't tell about these topics, that is the compiler design, OS, statistical analysis package, and DBMS, numerical analysis, simulation, artificial AI, graphics, everything, real-time application. Nowadays these are main topics under our all the application, how this AI and the graphics, OS, compiler, everything is based on these only. All these are dependent on data structure. Based on this data structure, with the help of the data structure only, these are the topics are derived. So these are the some of the application of data structure. That's all about introduction about data structure. Okay, what is my data structure? Data structure is nothing but this is a way of organizing data in the memory. This is the data structure. And why we are moving to data structure, and a real-time example we have discussed, and characteristics of correctness, time complexity, and space complexity. This is the classification of data structure, and these are the application of data structure. Now only we are moving to our syllabus. The unit one having the title is linear data structure. What is my linear data structure? The data are arranged in linear fashion or linear manner. This is the linear data structure. In that we are going to discuss about list and linked list. Okay, this linked list is one of the example of what is that linear data structure. What are the linear data structures we have? Anyone please list out the linear data structure.
Array, linked list,
Yes, array, linked
stack,
list, stack.
stack
Okay,
queue.
fine, very good. Pa. In this four already you have know about array. Okay, so that we are the syllabus is starting from list. Okay, array you have studied in previous semester. So now we are starting from list. In this list, we have some types: singly linked list and circularly and doubly linked list. Okay, three types are there. And so some applications and operation, all this data structure we can do the operation of insertion, deletion, and updation, and what is the traversal, everything we can do with all the data structures. Okay, in this data structure subject we are just going to discuss about what is already we are discussed what is data structure, and what is the types we have discussed. Now we are moving to each and every methodology, each and every data structure in detailed manner, and in that we are going to discuss about operation. What are the operation we can do with the data structure? We can insert a element, delete a element, update a element, search a element, traverse into the tree. Likewise, these are the things we are going to discuss. First unit talks about list, and second unit talks about what is that, stack. What's that? The second unit is talks about the what is another linear data structure is array, sorry, stack and queue. Okay, the second unit talks about stack and queue. The third unit is talks about the non-linear data structure, that is the tree, and fourth one is talks about the graph, the another one non-linear data structure. This is the over fifth unit talks about the search sorting algorithms. Okay, in data structure we can do that also. Okay, that main in this all type of data structure we can do what is that, insertion, deletion, updation. Likewise, we can do the searching and also the sorting of an particular data. This tree and graph, we can go with particular sorting algorithms. Lots of sorting algorithms are there. We are going to discuss in fifth unit about the sorting algorithms. Okay, now we can understand what is the flow going data structure, and its types and characters we have discussed. First unit is focused on list, and second unit stack queue, third one is the tree, and fourth one is a graph, fifth unit is the sorting algorithm. Okay, now moving into the what is the first unit. Okay, in first unit we have first topics algorithm analysis. What is mean by algorithm? Algorithm is nothing but it is a clearly specified set of simple instruction to be followed to solve a particular problem. When we are having one problem, then we need one algorithm to solve the particular problem. The algorithm consists of some simple instructions, sets of instructions having based on this algorithm we can solve the particular problem. Algorithms or the ideas begin the computer programs. Okay, how we solve the problem in computer with the help of program, where for example I want to add a particular thousands of records, thousand students marks, then I need one program to execute that particular problem, right? I need sum of all the marks, sum of all the thousand students marks. Okay, so I need one program to execute the particular sorry, need one program to solve the particular problem. For that, inside the program we have some algorithm. With the help of this algorithm we are doing the program, and finally get the output, that is the solve the problem. Okay, so the algorithm is nothing but it is a set of simple instruction to be followed to solve a particular problem. Okay, for example, example for algorithm in real time, I can say directions to somebody's house is an algorithm. Okay, we want to find one person house, means then we have some directions, go left and right and move there. Likewise, this is the algorithm. The next one is the recipe for cooking a cake is also one of the example for algorithm. Okay, this is the recipe having some sets of instruction to make a bake a cake. Okay, so this is the algorithm. What is the algorithm? Algorithm is nothing but this is sets of instruction to be followed to solve a problem. In the case of example, I want a cake. I want to bake a cake means I need to follow some sets of instructions. That is the algorithm. Okay. Now I think so clear. Is it clear? What is in the algorithm and move on to why. Next topic is what to analyze. We are going to first topic is algorithm analysis. For that, we are know what is algorithm and example. And next one is the algorithm analysis. Why we are going to, why we need of analyze the algorithm? Why? What's the reason why we going to analyze the algorithm? Why means to know about the performance. Okay, to know about the performance of particular algorithm, how to analyze, then only we can know this algorithm is what's better, or was or give better result, or not good manner working, not working in good manner. Likewise we can say with the help of analysis. Okay, so the analysis is very important in the case of algorithm. We have to analyze, we need to analyze, then only we can know which algorithm is best for which problem. Likewise we can predict and use that particular algorithm and fetch the better results. Okay, once an algorithm is given for a problem and decided to be correct, an important step is to determine how much in the way of resource that is used. Okay, for example, I want to bake a cake, and that I have two or more procedures. Okay, someone say one type of procedure, some other say another type of procedure. I have to analyze which one gives the best result. Which, who's that? Please mute yourself, students. Please mute yourself.
அவன் நேத்து சொல்லும் போதே நான் சொல்லியிருக்கணும்.
Pradap. Pradap. Hello, Pradap. Are you there? Okay, fine. Basics is very important to know about data structure. Please, students, listen. Then only you can. Then only the subject more in so much of interesting here. So first of all, you have to understand all the basic concept. Then only move to the further topics very well. Okay. This is the algorithm. Why we are moving, why we are analyze the algorithm? To find out which algorithm is best. Okay, and here in computer, why we are analyzing means how much the way of resource is used for a particular algorithm. Resource means in the case of computer where we can say time and space. How much time this algorithm is taken to produce a particular result, or how much space is used for a particular process or program. These are the main two terms main two terms for analyzing the algorithm. With the help of these only we can measure the algorithm, which one is best and which one is worst. Likewise we can analyze with the help of time and space. Okay, and also we have to know we have to know the algorithm is doing working properly or working uh, great. Likewise we have to know some all the algorithms are working good only, but which one is the best? That is the matter. We can write a exam in we can write an exam for all the 100 marks, but the main term here is we have to complete within 2 hours or 3 hours or 1 hour. Based on this constraint, we have to do. This is the process we are analyzing the algorithm. The algorithm works properly, no problem. Even we have to know it gives better results or no. Uh, assume the I already told the exam. Assume the example. We are going to write a exam. We can write all the 100 marks, or we can I can attend all the question. That is not a problem. Within 2 hours, how much can complete? This is the measurement we have to take to consider for a algorithm also. Okay, this is the algorithm, and why we are moving to algorithm analysis. And what to analyze, what is the thing, this is the topic in syllabus also, what to analyze, what are the things we are going to analyze. Already I told that is the main term is space and time. Here the main factor here is the running time. Running time is depends on how much time, the time, and also depending on the space. Okay, this running time is also again depend on the compiler algorithm, input to the algorithm, like this, which algorithm we are using, which compiler we are using, and which type of input. I am giving a simple input means that every algorithm gives the better results only. Once we are I'm moving to the large amount of inputs, very huge database or huge data sets, then only struggle to solve the particular problem. This is the things we have to know about, discuss about the analysis of algorithm. In detail we can say the correctness of the uh, algorithm, how it correctly identify the output or correctly give the output respect to the input. Next one is the amount of work done, how much amount of work done with respect to the time, and the amount of space used. And next one is the simplicity, how it is so simple to understand and do. This is the simplicity and clarity and optimability. Whether we can change and do some optimization further, we can whether I can do improvement in the previous one. This is the optimality. And time, complexity, space also, again it also discuss about the time and space. These are the things we have to discuss, or we have to analyze in the respect to the efficiency of the particular algorithm. Just these are the terms you have to know. These are the basic terms in terms of we are going to discuss about when we are discussing about the data structure algorithm, and what are the algorithm means, what is the example, and why or analyze the algorithm, what is the necessity or moving to the analyzing of the algorithm, and what are the things we have to focus when moving to the analysis of the particular algorithm or particular program. These are the things. Then what is the difference between data structure and algorithm means, data structure is the way of organizing and accessing data. In the case of algorithm, algorithm is a step-by-step procedure for performing some task in the finite amount of time. This is the step by step. That is the data structure is the way of organizing. Algorithm is the step by step procedure for performing some task in a within particular time. This is the difference between data structure and algorithm. Next, moving to the next one, that is the running time calculation. Have you ever hear about this terms, running time calculation or notations? I think so. No. Okay, pa. Running time calculation. In the case of running time calculation, we have to know about the some asymptotic notation. With the help of this notation, we can calculate the running time of the particular algorithm. Okay. With the help of some notations, we can find out the running time of the particular algorithm. In this we have three types. One is the best case time, next one is the average case time, and one is the worst case time. These are the three types under this running time calculation. Best case time is nothing but the minimum time required in executing the program. Within 5 seconds I can do. This is the best case time. Okay, within 5 times I can do. I'll at most it may take 1 hour or 2 hour. Okay, have you understood what I'm telling? Best case time is nothing but minimum time required in executing a particular program. That means for executing a particular program or algorithm, it may take of 30 minutes or 1 hour, and so I can do within 5 seconds. At most it take 1 hour, at least it takes 5 minutes. Within 5 minutes I can do. This is the best case time. Okay, for example, we are going to write exam. We are going to write an exam means some people the time duration is, the maximum time duration is 2 hours. Okay, we are going to write a exam, internal exam. The time limit is 2 hours. Some peoples are done complete the exam by within 1 hour 30 minutes. This is the best case time. Okay, the maximum time is 2 hours, but some people able to complete within some period, that is a 1 hour 30 minutes. Likewise they can complete. This is the best case time. Okay, I understood. This can be denoted by big O, just big O notation. This is no, denoted as big O notation, that is the upper bound. The next one is the average. This is some notations. Okay, the best case time is denoted by big O. The complexity and running time of a particular algorithm we can denote by this big O notation only. This is just notation to denote the running time of a particular algorithm. It can running time of algorithm represent by this O notation only. Okay, in further session you can clearly know what is that. And the next one is the average case time. Average case time already in the name itself you can say this is nothing but the average time recording executable. In average, how many students take it as the same example. We are going to write an exam. Average, in average, 10 students or 15 students are complete within 1 hour 45 minutes, means that is the average case time. Some may done with 1 hour 35, some may done with complete by 1 hour 50 minutes. Likewise, in average we can say within 1 hour 45 minutes most of the people are completed their exam. Likewise we can say this is the average case time. Okay, next one is the worst case time. Worst case time is nothing but the maximum time required in execute the program. Worst case, it takes lots of time. That means 2 or 30 minutes it takes. This is the worst case time. The maximum time we can say the 2 hours, but in the worst case, some people, some students may complete by 2 hours 5 minutes, 2 hours 10 minutes, 2 and 10 minutes. Likewise, this is the worst case time. Okay. Uh, is it clear, ma? We have three types in notations to calculate the running time. One is the best case time. Next one is the average case time. Next one is the worst case time. Okay. The average is denoted by omega notation. The worst case is denoted by theta notations. And also, the running time calculation means what is my running time calculation? Now we are discussing about what? Students, what is mean the running time calculation? Why we are discussing about the running time calculation? What are the topics now we are discussing? Anyone, please?
Number of operations happening in a certain time.
I'm asking what is the topic now we are discussing? From that only we are moving to the running time calculation. What is the topic we have discussed? What is
Yes,
that?
ma'am.
What pa?
Yesterday after getting notations.
No,
Ma'am, list, ma'am.
no, list still, no list. What is the topic we are discussing here? Then only from that topic only we are moving to the running time calculation. So far, what we have discussed. 45 students are there. Please respond. What are the main topic we have discussed in previous? From that only we are moving to the running time calculation.
Data structures and algorithm.
Yes, they're not a data structure, algorithm. We are discussing about algorithm and why we are analyzing the algorithm and how we can analyze. Then only we are coming to the running time calculation. Okay, how clear? We are discussing about algorithm, and in that algorithm we are analyzing the algorithm. Why we are analyzing? Try to find out which algorithm is best. Likewise, how to focus on analyzing. In that analyzing, how we can find out with the help of some terms, that is the running time calculation. How much time the particular algorithm is taken. From that we can know, okay, which one algorithm is best. Like this is the running time calculation. For that running time calculation, we have to know the some notations and three types of the best case, worst case, and average case. Okay, now this running time is uh, we have to find out running time. Okay, why we are find out? To find out which algorithm is best. For that we are finding the running time, and this running time is based on time complexity. This time complex is analyzed for two worst cases. First one is the very large input. Every algorithm works properly in single or a small simple amount of data set, but we are moving to the very large amount of data set, the very large amount of input. Then only we can identify which one is best. Okay, uh, we have another one term in general, that is in critical situation only we have to know which who is our best friend. Likewise, in the case of very large input only we come to know which algorithm is best. For a simple algorithm, simple data, simple problem, every algorithm gives better results only. So the time complexity is analyzed for mainly very large input size and also the worst case scenario. Worst case scenario means in critical situation. Based on these two, we analyze the algorithm means then we can find out which one is the best. Okay. For example, this is one of the polynomial here. How we can in the system we are having likewise only. This is one of the polynomial t of n equal to c 3n squared plus 2n plus 1. How we are going to find out the running time means for this statement, for this one single line, how we can find out. This is one polynomial here. In this polynomial, we are going to find out the running time, how this efficient. So for that, first step is drop lower order terms. Here the order is 2, here 1. Already you know, right? In max itself you know this. This is the, which one is the lower order terms, which one is the higher order here in this polynomial, which one is the higher order? What pa? 3n squared, right?
And so,
Okay, n square, this is the higher order. Keep this only and remove the remainings. Okay, this is the first step to calculate the running time for a particular polynomial. First remove keep only the higher order terms and remove remaining. This is the first step. And second step is drop all the constant multipliers. Drop all the constant. Which one is the constant here? 3, right? So drop the constant multiplier, remove that. Then we have only the n squared, right? This is the time complexity of a particular polynomial. Okay, this is the polynomial here. For this polynomial, the time complexity is O of n squared. Okay, is it clear, Pa? I take it one example, that is the Tn equal to 3n square plus 2n plus 1. This is one polynomial. For that, I am going to find out the running time. So I have two steps. One is the remove the lower order terms, just keep the higher order only. Okay, that means we are doing sorry, we are moving from one place to another place. Okay, for example, we are moving from Coimbatore to our college. Likewise, consider that example. In the Monday it takes 1 hour. Okay, Tuesday it takes 1 hour 30 minutes. Then which one is which one is we can say from Coimbatore to our college it takes which time? We can say 1 hour or 1 hour 30 minutes, students. What we used to say in Coimbatore to our college, it takes how much time? Like anyone asked, what we used to say in one day it takes 1 hour. Next day it takes 1 hour 30 minutes. So we can say only by 1 hour 30 minutes. At most time only we can say. Okay, within 1 hour 30 minutes, definitely we reach our college. Okay, from Coimbatore. Okay, so likewise we are selecting only the higher order terms, removing the lower order terms. Okay, and next one is the remove the constant value. So finally we have only the n square. The time complexity of a particular polynomial is order of the time complexity is represented by this notation, that is the order of O. Likewise only we have to represent. So the time complexity is order of n square. Okay, everyone is clear? Is it clear, pa? Shall we move on to the next one?
Yes, ma'am.
Okay. For that, for finding the running time calculation, we have some rules. First rule one, it is for loop. If our program having a simple program and having n number of values and doing some process, that is some addition operation or some other operation, anyone. But my program having only one for loop means the running time is order of n. That means it should be run for a n times, n number of times. So the order of particular running time is order of n. The running time of a for loop is at most the running time of the statement. How much it going to run, how much times the particular expression is going to execute, that is the time complexity or running time of a particular program. Okay, a program having only one for loop means the complexity or time complexity or a running time is order of n. Okay, the second rule is for nested for loop. You have nested for loop already, you know, right? You have studied in C. Nested for loop means more than one loop. One is outer loop, one is another inner loop. Each outer loop, each element, each statement, each execution in outer loop, all the inner loops are executed. Likewise means the running time is order of n square. Okay, this is the rule 2. For a single for loop, the time complexity is order of n, and the nested loop order of n squared, because here we are having this for loop is run or execute n number of times, and also the another inner loop also, sorry, another inner loop also execute n number of times, because we are denoting this will execute, in this also execute n times. So the complexity is, the running time is n cross n, that is n square. Okay, is it clear, pa? For a single for loop, the time complexity, the running time is order of n, O of n, and for nested for loop, O of n square. Okay, the next rule, third rule is consecutive statement, that is sequential statements. Then for that also the running time is O of n square. and further slides I have discussed, I will discuss some of the example. Then I have to know completely what is the uh, particular running time. Okay, this is for loop. In that we are having execute the value, that is the n number of time this for loop will execute. So the time complexity n, and here we have nested loop. So it will execute n square time. So we can finally, on the whole, we can say that is the n squared is the uh, time complexity for the particular program. How we can say means, for single procedure we have n, and multi nested procedure we have n squared. Within that we have to select maximum time. Okay, which one is the maximum time? The n squared. Obviously, compared to n, the n squared is the maximum time. So we can say the whole, on the whole, this algorithm or this statements have O of n squared. This is the time complexity. Okay, this is the rule 3. Next one is the rule 4, that is it is for if else statement. This also order of n squared, because in the case of if loop, we are doing some operation based on this condition. This condition may have n number of elements, so it will execute n number of time. It takes, what is that, time complexity of n. And also here else statements also doing n number of times. So we can say that these also order of n square. This is the 4 rules to derive the running time calculations. Okay, what is mean by running time calculation? It is based on time complexity, how much time, how much time it will, the particular application, a particular program or algorithm takes to execute a program and solve, sorry, get the results. This is the running time. Running time calculation is based on time complexity. And why we are moving to running time calculation? Need to analyze the algorithm, need to analyze the best algorithm. So that we are moving to running time calculation. In that, how we can find out, we have discussed. And we have some 4 rules for loop. What is the running time complexity? Time complexity or running time, running time. For nested loop, we have some order of n squared. And rule 3 is discuss about the sequential statements, consecutive statements. In that, the time complexity is order of n squared. And for rule 4 is the if else statement. Here also the time complexity is order of n squared. Why means, here if statements also doing one n operation, and here also the one of n operation. So the order of n squared is the time complexity for if else statements. Okay. Next one is the example. I'm having the for loop. Right here I'm having the for loop for I equal 0, I less than n, I plus plus. Here one important point is that for a declaration, time count is 0. Here no need to mention the time. This just I'm saying n. No, sorry. Just I'm saying here 1. No need to count this is not take much time. Okay, just declare the elements, declare the value into the particular variable. This is not doing taking more much amount of time. Next one is the I less than n, I plus plus. This I less than n take n plus 1 time. First I values there, and it repeats up to n times. So this is n plus 1. This will do n times. How you clear? Is it clear, pa? The in for loop, first I am doing the discuss about declaration. In that, no need to bother about time complexity. It is not take much amount of time. Next one is the I less than n, means is starting from I and doing process. So repeat up to n times. So n plus 1. And the I plus 1 is doing for n times only. And how we calculate? Finally add 1 plus n plus 1 plus n, so that we can get 2n plus 1. In that, I told already, what is that? Remove the constant multiplier, right? So remove the constant multiplier, that is the 2, to remove that. So the time complexity is order of n for this for loop. Already we discussed the rules for loop. And again we have one example in for loop. Okay, the next one is the if else statement. In if else statement we have two procedure. One is the if loop and one is the else. Sorry, one is the if statement, next one is the else statement. Either statement one will execute. So worst case is worst case this is the time complexity. Okay, from that we can take the statement one will take order of n time, because based on this condition if may give I less than n means it will execute n number of times. Okay, if within the if loop I gave some condition is I less than n means this particular statement will run n number of time. So this is the order of n, and the else statement is represent only by order of 1. Once the if loop is not executed, then moving to the else loop, right? Once the if statement is not executed, then moving to the else statement, that is the order of 1. Within that which one is the maximum, that is only we have to take, that is the order of n. This is the if else statement, how we can calculate for a if else statement. So for is it clear everyone? If you have any doubts, I think so time is over. If you have any doubt, please ask me. Four more essays, sir. Students, if you have any doubt, so far what we have discussed, what is my data structure? Please anyone, what is my data structure?
Arrangement of data.
Yes, very good. Arrangement of data. Why we are arranging to access? Why we are arranging?
Easily access that.
Easily access. Okay, we can easily search and retrieve the particular data, and we can arrange large amount of data. Without arrangement we can't do with large amount of size. So with arrangement in data structure we can manage large amount of data. And real time examples are dictionary, Google Maps, and Excel sheet. So please anyone can say Google Maps is the example for which data structure? Can anyone? Google Map is example for which type of data structure? We have many types, right? Google Map is example for which data structure? Which is linear or non-linear or array, list, stack, queue, tree, graph? Anyone please? Students, Google Map is example for data structure. Okay.
Yes, ma'am.
Then you can say which data structure. We have many types here: linear, non-linear, and in this, yes, please. No one.
Non-linear, no?
Non-linear, very good. In this non-linear, which one tells about Google Map? In non-linear also we have two types: tree and graph.
Graph, no?
Graph.
Yes, good.
Graph,
And
ma'am.
okay, pa. And dictionary, which is the example for
Linear, ma'am.
good.
Linear, array, no?
Okay, pa. Okay. Linear and list we can say. Okay, in this linear we can say linked list, because the words under a is arranged in first, and related to a the words which are starts with b, letter b, which is linked to the a, and so c and d likewise. So the dictionary is related to linked list data structure. Okay, good. Thank you, pa. And then applications in syllabus. What is algorithm? It's a collection of sets of instructions. And example for algorithm, and why we are analyzing, how to find which one is best. Likewise, so these are the terms I have to know in the case of analysis of algorithm. And running time calculation. Why we are moving to running time calculation? To find out the algorithm. Which one is the best algorithm? Likewise, you have to find it. So far, moving to the running time calculation. In that, we have 3 types. And this is all about find out the time complexity. And 4 rules are there. Up to this, we have discussed. So we can continue in next session. Thank you so much. Be interact sessions, then only it is interesting for you. Be interact. Thank you, students. Ma'am, next, which one is the next class, pa?
Ma'am, technical club, ma'am.
Okay. Shall I leave, ma'am?
Yes, ma'am. We are there.
Okay.
Thank you.
Okay.
Thank you, ma'am.
Okay. Thank you, students.
Good afternoon, students.
Malini ma'am, good afternoon.
Good afternoon, ma'am.
Good
Good afternoon.
afternoon. Yes. Welcome to the second semester.
Malini ma'am, am I
Thank you.
audible?
Thank you, ma'am.
Yeah, okay. Jaypurni, ma'am?
Ma'am, am I audible, ma'am?
Yeah,